Unit 1, Objective 4, Notes, Day 2. The first 6 questions are a review of the topics we have been working on in this unit so far. So I'm just going to go through. If you want, you can pause the video on your own, try the problem, and then check your answer with mine, just to see how you're doing on simplifying square roots with variables when the exponents are even versus odd, and simplifying square roots when you have a negative number. So those are the first 3 topics that we've been working on. Number 1, square root of 50, I'm going to break down into square root of 25 and square root of 2. So that 5 will come out, 2 remains inside. X to the 5th, we're doing square roots. So we're looking for pairs. So that's going to be x squared with 1x remaining. Y to the 7th, you're going to take 7, divide by 2, because you're looking for pairs. So that's going to be y to the 3rd, and again, 1y will remain. Now, we are mixing square roots with cube roots. Please pay attention to the index of the radical. That's that little number outside of the radical that's sort of tucked into that little corner. That tells you whether you're working with a square root or a cube root or another root that we're going to talk about today. So for the cube root of 8, we're looking for what number times itself 3 times is 8. And that is 2, because 8 is a perfect cube. X cubed, so when we're doing cube roots, we're looking for 3 of the same variable for 1 to come out. So that would be x, because you've got x to the 3rd. And y to the 6th, we're looking for 3 of the same, so 6 divides 3, and we get 2. Number 3, we have the cube root of a negative number, which is a real number. It's not an imaginary number. We can do cube roots of negative numbers. But 16 is not a perfect cube. So let me write the perfect cubes up there. 1, 8, 27, 64, 125, 216. So cube root of negative 16, I've got to break it down into negative 8 times positive 2. That negative 8, because 8 is a perfect cube, and of course we bring the negative with the perfect cube. So that's going to be the cube root of negative 8 and the cube root of 2. The cube root of negative 8 is negative 2 with the cube root of 2 remaining inside. 8 to the 9th, how many sets of 3 are there in 8 to the 9th? Well, there's 3. So that's 8 to the 3rd, and then I can trim this back a little because we just have 2 inside the radical. Cube root of 192x to the 11th. Okay, so 192, I don't know if that is a perfect cube. I'm looking at my 1, 8, 27, 64, 125, and I'm thinking no. But I'll take that 192 and I'll start dividing it by the perfect cube. So divide by 8. 192 divide by 27. 192 divide by 64. And that's 3 times. So this is going to become the cube root of 64 times the cube root of 3, because 64 times 3 is 192. The cube root of 64 is 4. There will be a cube root of 3 remaining. X to the 11th. How many sets of 3? Well, 11 divides 3 times. So that's going to be x cubed, but there are 2 remaining. So 3 divides into 11 3 times, because 3 times 3 is 9, 2 left over. Number 5, 5 cube root negative 81a to the 4th. So again, negative 81, not under our list of perfect cubes. So we're going to take our calculator and we're going to divide. 81 divides 8. No. 81 divides 27. Yes, 3 times. So carry the negative to the perfect cube. So that's the cube root of negative 81 times the cube root, whoops, let's try that again. Cube root of negative 27 times the cube root of 3. That makes the cube root of 81. Cube root of negative 27 is going to be negative 3, but there will be a 3 remaining inside. A to the 4th, there is only one set of a's, one set of 3, and then 1 remaining inside. All right, for the last one, we don't have a number inside, we just have variables with exponents. Ooh, you know what I forgot to do on number 5? I forgot that there was a 5 out front. So let me circle back to that. That 5 has to multiply that negative 3 that came out. So the final answer would be negative 15a cube root 3a. Number 6, we don't have any numbers inside, so all we're doing is simplifying the variables. A to the 5th, there's going to be one set of 3 with 2 left inside. B to the 7th, there's going to be 2 sets of 3 with 1 B left inside. All right, so that is simplifying square roots and cube roots. In Notes Day 1, we did simplifying, we did multiplying. Now we're going to talk about dividing with cube roots, and it's very similar to square roots. You're going to simplify the fraction first, and then you're going to reduce the radical. Remember, numbers and variables inside the radical of the fraction may only be reduced with numbers and variables inside the radical of the fraction. The same is true for outside. So remember, inside, anything that falls inside the radical when it's in the fraction can be simplified, reduced using your rules of exponents, and anything that is outside. So let's take a look at the first one, the cube root of 16 over 2. So I would take that fraction, 16 over 2, and I would reduce it, and I would get 8, making the cube root of 8 2. So that's a very simple start. For the second one, I would use the rules of exponents. 6 subtract 3 is 3. So that's going to be the cube root of x cubed, which is x. Rules of exponents says you subtract. If the fraction cannot be reduced first, then just separate and simplify. So a to the 6th, b to the 3rd, we can't simplify that. So we separate it, a to the 6th, b to the 3rd, and then we apply the cube root. So the cube root of a to the 6th is a squared, because there's 2 groups of 3 in 6, or 6 divides 3 is 2, and the cube root of b cubed is b. All right, so let's practice some dividing. All right, for the first one, we would simplify the fractions. You can go to your calculator if you want and type in 4 over 32 and reduce it. 4 divides into 32. All right, when we're simplifying and dividing, we're going to begin by simplifying what's under the square root. So for here, this would be the cube root of 1 over 8, because we're reducing 4 over 32. And then we would separate cube root of 1 over cube root of 8. And then we would simplify. Cube root of 1 is 1. Cube root of 8 is 2. So again, think about what it said up there. Simplify the fraction first, then reduce the radical. So let's look at number 8. We would simplify here by subtracting the exponents. 7 subtract 4 is going to give me 3. But when we do the y's, we're going to get a negative. And so we know that we're going to end up with a fraction. So on top, that's going to be x to the 3rd. But on the bottom, 2 subtract 8 is negative 6. Move it to the bottom to make it positive. Now you're going to separate cube root of x cubed on the top, cube root of y to the 6th on the bottom. That's going to give me x over y squared. So think about the cube root of y to the 6th. It's different than square root. You would have 6 of them, 1, 2, 3, 4, 5, 6. There's your first set of 3. There's your second set of 3. That is why it is y squared. And of course, the shortcut is to just divide the exponent inside by the cube root, by the 3. Let's talk about multiplying. When we're multiplying with cube roots or any other root, same rules as square roots. Multiply inside to inside, outside to outside. So here we're going to have a 7 because there's a 7 on the outside. Multiplied by the cube root of 25 times 5. That's going to give me 125. A times a squared, a cubed. B times b squared, b cubed. 7 times. The cube root of 125 is 5. The cube root of a cubed is a. The cube root of b cubed is b. Put it all together and you get 35ab. 125 is a perfect cube, right? If you are wanting to test that using your graphing calculator, you would hit the math button. I'm going to write that down over here. So you hit math and then 4, and then you'll see the cube root, and then you just type in your number. If the result is a decimal, obviously that number isn't a perfect cube. And then you'll have to do a breaking down, which we'll talk about again. 4 times 3 is 12, times the cube root of 2 times 4 is 8. The cube root of 8 is 2. 12 times 2 is 24. All right, number 9. Multiplying, we're going to get the cube root of 24. So if you were to test that in your calculator, you would see that 24 is not a perfect cube. 1, 8, 27, 64, 125, 216. Those are your perfect cubes. It's helpful to have them written down when you're working with simplifying. So which of those numbers divides into 24? Well, 8 does. So that's going to be the cube root of 8 times the cube root of 3, because 8 times 3 multiplies to be 24. Now, 8 is a perfect cube, so when that reduces, we get 2 cube root 3. As we mix square roots and cube roots, it's important to make sure that you place the number in the radical corner there so we know the difference between working, that we know the difference between the answer being a square root versus a cube root. Number 10, multiply everything inside and you're going to get 24 x cubed y to the 4th. Now we just broke down cube root 24, so we don't have to do it again. We already know that there is going to be a 2 outside and a 3 inside, right? That's what we got. The cube root of x cubed is x, and the cube root of y to the 4th is 1y with 1y left inside. Number 11, we have a 2 on the outside with the cube root of 8, a to the 7th, b to the 12th. So we're doing our rules of exponents, a squared, a fifth. Add those, you get a to the 7th, b to the 7th, b to the 5th. Add those together, you get b to the 12th. All right, the cube root of 8 is 2, multiplies the 2 out front, that's a 4. The cube root of a to the 7th is a to the 2. So 3 goes into 7 2 times. And of course, there will be an a left over. Cube root of b to the 12th. There are 4 sets of b in 12. 4 sets of 3. Or 12 divides 3 is 4. And that's our answer. Okay. Let's talk about an alternative way that we can work with different roots, square roots, cube roots, and then we might change that number to a 4th root or a 5th root. And another way to work with that is using something called rational exponents. Okay, so rational exponent, a fractional rational exponent. The word rational is just a fancy name for fraction. So we can take any radical and we can rewrite it as a base with a fraction exponent. So here's where the values go, or where the fraction goes. So x raised to the m over n, the denominator of the fraction, becomes the index of the radical. The numerator of the fraction is the exponent of the variable. I want you to notice that there are two equivalent ways you can write it. So look at the diagram with the colors. X raised to the m over n. M is your power, your exponent. It can either be written inside the radical or outside the radical. But the index always is positioned in that little corner of the radical. So x raised to that fraction m over n. N is the index, m is the power. And I'm going to do some examples with you to explain why you can do it either way. All right, I prefer, so I'm going to put a box around this one. I prefer doing it this way, so I will always write it this way. I will always root, then power. All right, I will always do the root first, and then I will raise it to the power. And again, the denominator of the fractional exponent becomes the index of the radical. The numerator of the fractional exponent becomes the power of the value under the radical symbol, or the power of the entire radical. Two common exponents that are fractions. One of them is when the exponent is a half, and the other one is when the exponent is a third. So I want you to take a look at the equivalency here. So x raised to the 1/2 is the square root of x. X raised to the 1/3 is the cube root of x. So the square root of a number, or the square root of a variable, can be rewritten as a base with a fraction exponent. Now you can verify that on your calculator, and I want you to look. We've got radical form and we have exponent form. Radical form is obviously gonna contain the radical symbol. Exponent form, the exponents are going to be fractions. So take a look, the square root of 25. On your calculator, type in 25 raised to the 1/2, and you're going to see that you're going to get 5. So the square root of 25 is the number 5. 25 to the 1/2 is 5. You should be able to verify that on your calculator. The cube root of 27. 27 is a perfect cube. That's 3. 27 raised to the 1/3. Try that on your calculator. Take 27, then use the caret button, which is above the divided by, and then type in 1 divided by 3. Or you could use the caret button and then the math, or the alpha y equals, to type in a fraction like that. You should get 3. And then the third example there has a 4 in the index. This is known as the fourth root. The fourth root. And the fourth root of 16 means what number multiplied by itself 4 times is 16. That's what the fourth root means. On your graphing calculator, if you hit the math button and then you hit item 5, you are able to change the index to a 4. So the answer here is 2. But if you don't have that, another way to do it is to take 16 and raise it to the 1/4, and you will get 2. So one of the first things you're going to do is you're going to practice rewriting from radical to fraction exponent and from fraction exponent back to radical. So remember, the top of the fraction is the exponent. The bottom of the fraction is the index. So square root of 5 can be rewritten as 5 to the 1/2. The cube root of 10 would be written as 10 to the 1/3. The cube root of a squared would be written as a, and then 2 is the exponent, and 3 is the index. So a to the 2/3. So it's important to know where those numbers go. So 32 to the 1/3 would become the cube root of 32, because 3 is in the denominator of that fraction exponent. So that means it's the index, and then 32 raised to the first power. You don't need that. This is the square root of 6. Now you might think, why didn't you put a 2 in that index? And the answer to that is because we've never put a 2 in that index. So we wouldn't need to start now. Xy to the 1/3 is the cube root of xy. So 3 is my index. It's really important, and maybe I even do a better job, that you tuck that 3 into that little corner of the radical so that you don't think that it is 3 times the square root. Really important. All right, so when you're rewriting from exponent form to radical form or radical form to exponent form, the blank of the radical, so the index, of the radical becomes the denominator of the rational exponent. Follow rules of exponents to simplify expressions before rewriting. Okay, so the square root of 16 would be 16 to the 1/2, and that would be 4. Square root of 16 is 4. 8 to the 1/3 is the cube root of 8, which is 2. A squared to the 1/6. Well, what's our rule of exponent? That's going to be 2 multiplied by 1/6, which is 2/6 or 1/3. And that converts to the cube root of a. 2 to the 18th raised to the 1/6. Well, rules of exponents. 18 times 1/6 is 3. So that's going to be 2 to the 3, which is 8. X to the 4th, y to the 10th to the 1/2. Rules of exponents. 4 times 1/2 is 2. 10 times 1/2 is 5. Recall from Unit P that you can type exponential expressions into the calculator to determine a numerical answer. Remember to use parentheses and the alpha y equals fraction menu if you have the graphing calculator. So 36 to the 1/2, you could literally type that in your calculator and it'll do the answer for you. Or you can rewrite it as the square root of 36, which is 6. 8 to the 1/3, that would be the cube root of 8, which is 2. So if you don't have the calculator, you will have to convert it and simplify it. Okay, 27x to the 3rd, all right? So that's going to be the cube root of 27x to the 3rd. So please make sure that you know how to rewrite from fraction exponent to radical. So fraction exponent 1/3, radical cube root. Now simplify. The cube root of 27 is 3. The cube root of x cubed is x. 8 to the 2/3. So again, type it in your calculator or rewrite it. The cube root of 8 squared. You could also write it the cube root of 8 squared. So I want you to notice that it can be written both ways. And what I mentioned earlier was I prefer this way. I'm underlining it in purple. And the reason is I would rather cube the number, get a smaller number, and then raise it to the power. Because for the second one, if I take 8 squared, that's 64, I'm cube rooting a larger number. Either way, you're going to end up with the same number. So the cube root of 64 is 4. Over here, the cube root of 8 is 2. 2 squared is 4. Look, we end up with the same number. Or you type it in your calculator. But please make sure you know how to convert, because that is something you will get quizzed on. So you can go ahead and do the numerical ones in your calculator, but you do have to know how to convert. All right, last one here, 64 to the negative 2/3. That's going to be 1 over 64 to the positive 2/3. And again, you can type that in your calculator if you want, or you can practice rewriting. That's going to be 1 over the cube root of 64, and then I'm putting the squared on the outside. Cube root of 64 is 4, so that's going to be 1 over 4 squared, which is 1 over 16. All right, now what about when we start adding some variables in there? Again, please make sure you know how to convert to radical and then just do your normal simplifying. So 1/3 exponent means cube root, 125 x to the 9, y to the 12th. And now you just simplify. So the cube root of 125 is 5. The cube root of x to the 9th is x to the 3rd. And the cube root of y to the 12th is y to the 4th. So rewriting it as a radical means you're just using the rules of simplifying that we did at the beginning of these notes. Cube root here of 64, x cubed y to the 6th. Cube root of 64 is 4. Cube root of x cubed is x. And the cube root of y to the 6th is y squared. Again, normal simplifying. All right, so we're almost done with the notes here. The last topic we're going to do is what happens when the index is something different, like a 4th root or a 5th root. You're going to do the same thing you did with cube roots, all right? Keep thinking about what it meant to have a cube root. It was 3 of the same. So for 4th root, it would be 4 of the same. Or 5th root, it would be 5 of the same. Nth root, you would need n of the same number or variables inside the radical. Remember to use your rules of exponents first if it makes the problem easier. So 32 to the 1/5. So that denominator of 5 is the index. So that's the 5th root of 32. So in your mind, you're thinking, what number multiplied by itself 5 times will give me 32? You can also use the math menu on your graphing calculator. So you will hit math, and then you will hit 5, and it looks like this. It's got an X where the index is, and then a blank. Now, when you choose that, what's going to happen is you're going to see ANS, it's weird, and then radical, and then a blinking box, right? You have to change this to whatever the index is and then type your number in. So you would have to put 5th root of 32 on this one. And it will turn out to be 2, because 2 multiplied by itself 5 times is 32. All right, so let's simplify these, and then maybe I'll let you try 1 or 2 on your own. So the 4th root of 16, x to the 4th. All right, so what number multiplied by itself 4 times is 16? 1 times 1 times 1 times 1 is 1. 2 times 2 is 4 times 2 is 8 times 2 is 16. So the answer to the 4th root of 16 is 2. You could, if you wanted, also to go to your calculator and take 16 and raise it to the 1/4. Then you don't have to worry about using the math button, or you don't have to worry about doing the mental math. The fourth root of x to the fourth. So we need 4 of the same. We already have 4 x's there. So the answer is x. The fifth root of 32. We just did that one. That's 2. A to the 6. So let's think about that. 1, 2, 3, 4, 5, 6. There's 5 of the same. 1 comes out with 1a remaining inside. For number 22, we're going to use our rules of exponents. So that's going to be 3 times 1, 6. So that's going to be 36 times raised to the 3 times 1, 6. Well, 3 times 1, 6 is 3/6, which is 1/2. Go to your calculator, do 36 to the 1/2, or remember that it is equivalent to the square root of 36, which is 6. 32 to the 1/5. So for all of these, if we wanted to, we could just apply the rules of exponents. So here's an alternative way to do it. 32 to the 1/5. X, well, let's see. If we did 5 times 1/5, it's just 1. Y to the negative 15 to the 1/5 is y to the negative 3. Because I'm doing my rules of exponents where I'm multiplying the powers. 32 to the 1/5, we already know what that is. That's 2x. And then, of course, we have to move the y to the 3 to the denominator. All right, last 3, and then our notes are done. 9 to the negative 1/2 is 1 over 9 to the positive 1/2. Rules of exponents. Go to your calculator, 9 to the 1/2. Calculate that, or rewrite it as the square root of 9, which is 1/3. The next one is an exponent of 1/2. Well, that's square root. So you just learned that is the square root of 24, a to the 5th, b to the 8th. Well, now we're back to what we did in objective 1, breaking down. And notice this is the square root, not the cube root. Okay, so that's going to break into 4 and 6. Not 8 and 3. So we're not thinking cube roots. That's the hardest part about this, is making the distinction between square roots and cube roots. So a 2 is going to come out, and the 6 is going to stay inside. A to the 5th, we're looking for pairs now because we're square root. So we're looking for pairs. So that's going to be a squared with 1a left inside. B to the 8th, that's going to be 4 b's coming out. Last one. Cube root, because it's 1/3 power. So I'm going to rewrite it as the cube root of negative 27, a to the 6, b to the 10th. So now we're switching our minds to cube roots. And we have a negative. And when we cube root, we're thinking of 3 of the same. So the cube root of negative 27 is going to be negative 3. Now I want you to know you could have also gone to your calculator and done negative 27 raised to the 1/3. Notice you have to keep the negative 27 in parentheses, and it would give you negative 3. Cube root of a to the 6 is a squared, because you're going to do 6 divides 3. Cube root of b to the 10th is b to the 3rd, but of course we will have 1b remaining. And of course we need to remember that index of 3 for the cube root.